There are many areas of research being pursued here at ECE by members of the Energy Systems Group. What those pursuits have in common is the objective of making the electric grid more reliable, more efficient, and having the flexibility of accepting renewable energy systems. For over 100 years, the electric grid has been supplying energy and power to a critical infrastructure. Some people might argue in favor of the current grid, but it's becoming obsolete because the greenhouse emissions are just too high. We need to improve the grid to enable green power generation.
We have to put solar panels on rooftops. We have to have small wind turbines where the area is adequate for that. We have to take advantage of the water resources where those are available in the community. So the new model will be based on small distributed generation.
All of these systems, though, particularly wind and photovoltaic, have the problem that the energy is not constantly available. It's only available when the sun's out or when the wind is blowing, for example. And this causes problems for the utility because they have to cope with energy coming in at times that they perhaps don't want it to come in.
So it's a real challenge. We need storage to make up the difference so that when we have excess generation, we can store it, and when we lack generation, we can borrow it from the storage.
This is a building scale energy system, and what we do with this system is convert AC coming from the grid and store it in this battery pack that it's 250 kilowatt hour. When the building has a high power consumption, what we do is we inject it back into the grid using this inverter. This is what we call peak shaving.
Now we have a situation where there's more and more alternative energy sources. Things like wind farms are going up, which are causing a real problem in places like Germany. The producers are being asked not to produce because the utility can't cope with the input. So if we can control the loads better to match the inputs from these sources, then we can make much better use of those facilities. Another thing we can do with the batteries is to use them to compensate for changes in the load in the building as a sort of smoothing system. So as the building load goes up and down, those variations can come from the battery rather than from the line, because the utilities like to have loads which are as constant as possible. One of the Vancouver companies I work with is in the business of load management, which means that over the internet, they can control loads in things like industrial sites in order to match the requirements of the utility. As you change these loads, the losses in the system also change, and there will be a point at which the efficiency is optimum.
If every little community that has its own generating solar, wind generating plant has to have enough storage for providing the demand as required, that solution becomes very expensive. So this small generation has to be connected one with each other, forming microgrids and other alternatives, but being able to share storage through the existing grid.
We cannot really expect to replace the vast amount of energy that's required now by society simply with alternative energy. If we want to stop using carbon-based fuels, we really then have to reduce the amount of energy we use for our daily life.
We have to be able to provide energy to 14 billion people by the year 2030 or so. And we have to do that while preserving the planet. That is the main challenge of power system engineers.